So on to our next sponsor talk from LECO. This is Flavio with the talk title of Evaluation of Sample Conditions for Volatile Metabolites and Exhale Breath Combining Trap, Enrichment, Dual Stage Thermal Desorption, Comprehensive 2D-GC Mass Spec. Over to you, Flavio, and we have Richard joining us for questions at the end.
Good afternoon, everyone, and thank you for following my presentation today. My name is Flavio Franchina, and I am an associate professor at the University of Ferrara, where I am responsible of the GCMS laboratories. And today I'm gonna talk about our research on volatile metabolites in breath and culture samples. Okay, I start showing you the platform we currently use for the analysis of volatile metabolites using the dynamic headspace extraction technique. The platform consists of a GC-GC TOFMS system, which is very versatile for different type of samples. And the picture here shows the most important features. So as a first feature, this is the tube decapping station, which allows the handling and automation of the sample tubes for the analysis. As you can see here, the tube is placed inside this box and automatically capped or decapped for further analysis. As a second feature, very important, is the placement of the tube inside the injector port for thermal desorption. And thanks to this liner or tube exchanger, and then we have like a multi-mode inlet, which allows rapid thermal desorption. The presence of an auxiliary gas flow controller allows for a dry purge of the sample tube for successful water and oxygen removal before the analysis. And this also ensures that no air is going into the system during the inlet opening. Inside the oven, there is also a cryogenic trap, which ensures a secondary focusing and release of the analytes in the chromatography column, and with benefits in terms of sensitivity and also in terms of like peak shape and chromatographic resolution. Following, we also have the presence of the GCGC modulator. In this case, it's a cryogenic modulation used for improving and getting all the benefit of GCGC, but for time reason, I don't have time to show them. Going into the application, when we want to sample from biological samples for whatever is the objective of the study, so for diagnosis, prognosis, biomarker discovery, many are the scenario to face. In vitro and ex vivo samples, for example, with their relative advantages and disadvantages. And of course, when planning, we should usually consider both approaches together for complementary information and to support hypothesis-driven research. However, when the scenario of in vitro and ex vivo samples is very complex, also from a sampling and analysis point of view. If we take as an example the case of exhale breath and culture samples, even if we try to reduce the complexity, focusing to the smaller metabolites only, still physical chemical differences exist between the two sample types, for example, the humidity of the samples, physical state, the complexity, affecting these steps of the analytical process. The sampling technique, indeed, is one often analytically underestimated, and this factor may have contributed considerably to the lack of consistency when reporting biomarkers, hampering its large-scale acceptance and use. And if we look at the literature, SPME is the most used for in vitro samples, for example, while trap tubes are the most common for breath analysis. And in our case, we use the latter. We use thermal desorption tubes for our workflow for the analysis of volatile metabolites. And this is especially true when we want to compare in vitro and ex vivo samples. And I'm going to show you one of our comparative study for the sampling conditions. And indeed, the use of the same sampling technique and conditions to approach two different samples give a less biased extraction of the analytes and thus a better comparability. And in this study, compared the recovery of extraction using different tubes types packed with singularly or multi-bed with different adsorbents, both exploiting porous polymer and graphitized carbons, into different sampling setups. One in vitro sampling setup and two an in vivo sampling setup. So this is the setup we use for in vitro sampling. Here the sample was a culture media that we spiked, and on the list on the right, you can see that the list of the standards we used as a spike in the culture media that we used for the evaluation. And assembly conditions, we used 37 degree and 1 liter of dynamic headspace extraction volume at 200 ml per minute. This bar plots shows the response obtained with the different tube types, and I know it's a lot, but I will resume for you the most significant observation. As first, you can see that there is a variable response between the different standards, regardless of the tube types used for the extraction, and this variability is not only due to the different initial compound concentration in solution, which was from 0.7 to 1.5 ppm, but it's importantly related to their availability in the headspace and the trapping efficiency of the tube type itself. The headspace concentration is indeed influenced by the boiling point, the solubility in the media, in the aqueous media, and the partition of the analytes between the serum and the headspace. Since all the experimental conditions were maintained constant, the difference that we see in the response observed between the tube types can be associated with to the capacity of the adsorbent to trap the specific compound. And so we can also see that like 3 of the 19 initial standards, the butandiol, hexanoic acid, and the xylamine were not detected in any of the in vitro sampling analysis independently from the tube types. So going to the sampling setup for in vivo sampling, so for breath sampling, here we relied on sampling using tailor bags. And the nice innovation we did here was to use this flash vaporizer that we used to spike breath samples with the same mixture as for in vitro samples. So in other words, we were able to recreate a scenario of target analytes within the breath matrix. And so also for this, we use the same transferring condition as for in vitro. So 1 liter, same concentration of standards, and at 200 ml per minute. And again here, looking at the bar plots, showing the response obtained with the different tubes, we can see that obtained similar results as in vitro. And from this view, it's difficult to pick, let's say, the best performing tube type for this application. And instead, if we look at the reproducibility of the methodology in both setups, we can now see that there are some differences which can help selecting the best sorbent trap to use. We can see indeed that tubes packed with Tinax showed the lowest relative standard deviation. We can also see that an improvement of RSD within the same tube type was observed compared to the in vitro setup, and this can be explained by the physical state of the target analytes, which were already in the vapor phase after the flash vaporization during the extraction, and compared to the in vitro conditions in which there are additional variables to involved, for example, the partition and the affinity with the aqueous media. And here is another nice example that I want to show you as an example of longitudinal sampling. In this case, we measured XL breath metabolites at several time points after coffee intake, and we monitored some target analytes. And some of these target analytes are these nitrogen-containing compounds, which are very characteristic of coffee. And again, here is the response obtained with 3 different tube types, and we can see how important is the selection of the tubes. In the case of this methyl pyrrole here, a poor selection. So if we consider the third tube, so we would risk to miss totally the analyte. Otherwise, in the other cases, having like a better response, it allows to also track more in time the selected metabolites. So it's very important. And going to the conclusion, so I showed you that the analytical platform we used for the analysis of volatile metabolites in breath and cultures allowed to perform online and dual stage thermal desorption, followed by GCxGC-TOFMS, combining in all these platform the benefits of the selectivity, sensitivity, separation power, and also automation. When a correlation and translability is sought between in vitro and in vivo or ex vivo samples, an harmonization of the analytical procedure should be considered. And for breath and culture-based experiments, the use of traps is valuable to maintain the same extraction conditions and thus comparable results. Harmonizing the sampling technique and conditions to approach indeed to different sampling scenarios gives a less biased extraction of the analytes and so a better comparability. It's also very important to reduce the analytical variability because understanding the biology is already complicated. And in these examples today, I showed you that tubes packed with Tinax resulted the best performing for non-targeted analysis in breath and culture, which are humid samples. And finally, I would like to thank you again for the attention. I also thank my research group at the University of Ferrara, my collaborators in this topic from the University of Liège, my industrial partner, and again, you for the attention.
Excellent. So we have time for a couple of quick questions if Richard is there. Can you hear us okay, Richard? You're on mute.
I can hear now. Or you can hear me even.
I can hear you. I can hear you. Thanks for joining us to take a few questions here. So if you come through from the listeners, is pre-concentration of the VOCs performed?
Yeah, so on Flavio's systems, the pre-concentration happens in the cryotrap at the head of the analytical column, using liquid nitrogen or and this is what concentrates those VOCs into narrow band and helps with the detection of the trace components and also the peak shape as well during the analysis, as was shown earlier in the slides.
Fantastic. Two questions here. They're somewhat related. Can you explain further why the choice of sorbent tube is critical for detecting certain compounds? And then the next one is, would you suggest Tanax as sorbent material for analysis of a wide range of compounds when compared to other sorbent materials? Or do you have other recommendations?
That's when I'm going to have to take back to Flavio for a little bit more detail on that side. Unfortunately, he wasn't able to join us today due to teaching commitments, but I can take those questions away and definitely get you an answer for when the recording is released. That
sounds good. And one question I have related to when you speak to them, particularly aldehydes. So we'd love to know if there's sorbent materials that have worked well in your guys' experience. Looking at aldehydes, they popped up a few times in some of the earlier presentations today. Next question here is, how long does it take to trap VOCs in the tubes?
I'll have to have a little bit of a stand-in for the technical details there, but you know, I'm happy to take these questions away and make sure we get full answers from Flavio for each of these.
Sounds good. Sounds good. Last question on the GCGC. Can you talk a little bit about the different types of column chemistries that you might recommend to anyone doing breath research?
Yeah. For this particular application, Flavio was using a 624 phase on the primary column, so that was 30 meters at a 0.25, and then he's combined that with a 2 meter by 0.25 watts column. So they've got off-agonal chemistries there, and having that different polarity and different chemistries there, that provides more peak capacity, and ideally we just want to separate those components a little bit further so we get more accurate quantitation and also more accurate identifications. So it's an interesting technique if you're dealing with extremely complex samples and are struggling with identification or quantification problems, and one to consider.
Wonderful, wonderful. Well, thank you so much for joining, Richard, for a few questions there. I'd love to know the aldehydes, best sorbent for aldehydes. We'll be keen to hear back on that. So thanks again, Richard.
Okay, thanks for having LECO as a sponsor. I look forward to the rest of the session.
Appreciate it. Appreciate your support.